This will be the last video for hypothesis testing for population means. After this, we'll be getting into population proportions and then also population differences. So let's take a look at this one. It is recommended to have a dental examination every 6 months to promote proper oral hygiene. A survey of 16 random individuals reveals that the average time since their last checkup was 8 months, with a standard deviation of 0.7 months. Are people waiting longer than their recommended time period between checkups? Okay, so again, we're going to move through that same step for the hypothesis testing process. State the null hypothesis. 1, we have H naught. This is just the way we write it to say that this is the null hypothesis. Mu, the assumption that we had prior was that, or it's the recommendation. And we want to see if people are following that recommendation, right? It's recommended to have a dental examination every 6 months to promote proper oral hygiene. Well, we need to see if people are following that advice. So the assumed wait time is 6. 2, what we want to test is, are they waiting longer than that? Well, that's going to mean mu is greater than 6. Okay? So 3, is this one-tailed or two-tailed? In this case, this is a less than or greater than sign, so it's 1. And again, I haven't done any two-tailed tests yet, but this would be the situation where mu is not equal to 6. Okay, that's not the case here, but that's how you get to. The next question would be, is this a Z test, like a standard normal test, or is this a T test? Because again, we're testing a population mean, so we're either going to be a Z test or a T test. Well, that depends on what n is. In this case, the survey, the sample, is of 16 individuals. So this happens to be less than 30. And so we know that this has to be the T test. Now, anytime you have the T test, you need those degrees of freedom as well. So df is equal to n minus 1, which is equal to 15. All right, so let's go through this. The rejection region. Now, because mu, like in the last couple videos, our rejection region was always below the average. So if I were to draw my mean, in the last couple of videos, it was always down here because mu was less than the average. Well, now mu is actually bigger than the average, so that means that our rejection region is going to live up here. Okay, subtle difference, but it just means that our T alpha is going to actually be positive now. So T alpha in this case, and I'm going to get out my chart again. Again, what we're going to be using alpha equals 0.05 almost exclusively through this class. It just makes life easier for all of us. So 0.05, this is a one-tailed test because we know it's one-tailed, so we know we're looking at the one-tailed column. And degrees of freedom, we decided were 15. So we're going to go to 15 and we're going to go over to 0.05, 1.753. So T alpha is equal to 1.753. Unlike the last videos, these aren't going to be negative because now T alpha is bigger than 0. So this is equal to 1.753. So we figured out the rejection region and the little the critical value that goes along with that. And then 4, we got to find that test statistic. So T equals. So again, we're going to look at our trusty formula sheet. X bar minus mu divided by S over the square root of n. Same thing as the Z, it just has a T. So T equals X bar minus mu over S divided by the square root of n. So this is going to be, well, X bar, what they tested was that the average time since the last checkup in the survey, in the sample, was 8 months. And the tested mu value is going to be 6, because that's the null hypothesis. And the standard deviation in that sample happened to be 0.7, and we're going to divide that by the square root of n, so the square root of 16. Oh, sorry, I put the mu there. This should have been a 6. So this is equal to 2 over 0.7 divided by 16, square root, is equal to 0.175. 2 divided by 0.175 is going to give me 11.43. So 11.43, this happens to be much larger than 1.753. So this is going to be 11.43 up here. When it's in the rejection region, the conclusion is 5. We reject the null hypothesis with a 5% chance of type 1 error. Okay. And then 6, we just have to interpret that conclusion. We say that there is sufficient evidence. And I like to say suggest more than conclude, because you really need to test these things. These things are always fallible, right? There's always a 5% chance of that type 1 error. But I like to say there is sufficient evidence to suggest that, so I say suggest because everything's still, like, it's not certain. To conclude, you want to be 100% certain. There's no 100% in statistics. There's just pretty darn likely. There's sufficient evidence to suggest that people are waiting longer than the recommended 6 months for an examination. Okay.